In this video, we are going to look at logging and monitoring for the data platforms and how query logs can be used to investigate platform activity. So, put on your detective hat and let's go! In the previous videos in this series, we talked about preventing unauthorized access to data platforms, and we covered identity and access management, who can access the platform, data access controls like row-level security, and that means what they can see, what data they can see, and network security, from where they can connect to our platform. But even if all of those are configured correctly, one important question remains. How do you know what actually happened in your system? Because if you cannot see the events in your system, then you don't really manage it and you cannot react in a correct way to any of the incidents or issues that arise. In practice, most data breaches don't happen because someone hacked your system, and I was saying that many times already. They happen because someone used legitimate access in illegitimate way. So it might be just one of the users doing some mistake, or by misconfiguration someone got extra access that they don't need. And the example could be an analyst. They can export an entire customer table, or let's say not analyst, but let's say a data engineer for some reason, or a service account that starts querying unexpected data sets, or someone attempts to access data they shouldn't have access to. And from the platform perspective, those are just queries, and which is why monitoring and logging are such an important part of data platform security. Now, monitoring answers questions like who queried which dataset, when did it happen, which role was used, and was the query successful or was it denied, was it failing. Without this information, it becomes extremely difficult to investigate incidents. But modern data platforms have a big advantage compared to traditional systems. Their operational logs are often exposed as data. So it's not like you have a file sitting somewhere else and you need to parse it, but instead all of the logs themselves are queryable using the same SQL. And instead of digging through those files, as I mentioned, or trying to export the data into a separate system, engineers, security engineers, can investigate activity directly using queries. For example, in Snowflake, and that is the platform that we are going to use for today's demo, activity is stored in views such as query history and many others that we will cover today. And it means that you can analyze the platform behavior the same way you analyze business data. But there is a simple principle here. Security logs are useless unless they are easy to query. So if you have a very robust and meaningful logs that are hidden somewhere and you cannot access them, then it basically means that you don't have those logs. But if you have good enough amount of information in logs that are immediately available for you, that is a much better situation. So if you can filter by users, time ranges, roles, query text with like comparison or years, all using the standard SQL, you are in a very good position. And this turns operational telemetry into something that security engineers can actually work with. And another interesting aspect of modern data platforms is that they basically blur the line between different operational roles. Traditionally, you had database administrators who focus on database performance, then security teams who focused on audit logs, and last but not least, DevOps teams that manage the infrastructure. But in many modern data platforms, all of those areas are kinda intersect and mixed together. The same telemetry data can answer questions about performance, usage patterns, and security incidents, which means that the data engineers and the platform engineers increasingly need some basic security investigation skills. Hence, this video that might help. And this is important because many real incidents look like a completely normal activity. An attacker doesn't always break into the system. Sometimes they obtain legitimate credentials, so they used their social engineering skills to steal the password and the username from someone, or just a user with valid permissions access the data in a way that violates the policies, and that's it, you have a data breach. Good examples of those activities could be exporting of large volumes of data or querying data sets outside of their normal scope of work, or potentially repeatedly attempting to access the restricted tables. It can be a red flag that something fishy is happening, or maybe just someone is not exactly know what they are supposed to do. And once again, that is why monitoring query activity is so important. Of course, in real environments, nobody manually checks query logs all the day with queries every 5 minutes to just see what's happening right now. And monitoring queries are usually connected to an alerting system. It could be a centralized monitoring platform like Datadog or Splunk, or a scheduled detection jobs running directly inside your data platforms, which is, well, possible as well. And when suspicious activity is detected, then the alert will be triggered and then the investigation will begin. That's where you will need your detective hat. In this video, we will focus only on the investigation part, and the next video, we will look at how alerting and detection can be implemented. Now, let's look at simple example in Snowflake. I created a trial account on Snowflake, and I have 3 different users. One of them is my current user, which is a pizza selector, and he is an account administrator at the moment, and he will do the security investigation itself. On top of that, we created for this user some fake data. So imagine it is a healthcare database with a production schema, and inside of this database and schema, we are going to create a table of patients with just patient ID, name, diagnosis, and a Medicare number. As you can imagine, this could be somewhat of a restricted data, and that is the idea. Then we insert some fake data into the table, and we can run the query and see that, yeah, we have our data available. Then to continue the setup, we create 2 roles, the analyst role and the data engineer role. The analyst role is a legitimate user who is supposed to check what's going on with those patients and how that data can be used for the hospital performance, for example. And the second role is a data engineer, which should be focusing only on the data ingestion and the data transformation activities, but not have direct access to the data itself. So we create 2 users, Alice and Bob, and you can guess who is who with the same passwords. And we create the role, we grant the role analyst to Alice, and we grant the role data engineer to Bob. But in terms of the role setup itself, I will repeat my mistake from the very first video in this series, and I will grant all and grant select on specific table to analyst and to the data engineer. Basically, the role-based access control setup, the role setup is exactly the same between those 2 roles, and that is incorrectly set up, so misconfiguration. And to show what is going on, we can go to Alice, and here I have logged in as Alice. I can use the role analyst, and I can select everything from that same healthcare patients table, and that is a completely normal behavior. Nothing should be suspicious about this one. But then we can switch to our Bob person. So here I logged in as Bob, and I'm using the role data engineer. Now I can still select everything from healthcare patients, which is already not so good, but on top of that I can try to create a whole dump of data as my copy, which is definitely not something that should happen in a production environment. So it is still possible to create this table my copy, but actually I already did this. So if I will run that query again, it will fail with my copy already exists. That will be used later in a demo. So imagine after all of those activities, some sort of alert triggered, and we got notification, and now it's time to investigate what is going on. in order to do that, we can use a couple of queries, all using the Snowflake account usage schema, database and schema. The very first query that you can run is to check when the users were logging in and who were logging into your system. So we can see that both Bob and Alice and Pizza Selector were logging in during the time frame of today-ish, because here the event timestamp, it is in different time zone. So the times over here are not necessarily the same that I have on my clock. Then the interesting bit, it could be to check what kind of queries are they using. So for that we are going to use the query history view, and this is a very important view that can be used for many interesting investigation activities. So the very first one is we can run the query text that is like patience. So that is our table name, and we can see what kind of query was that. And we can see here that the Alice did the select star and Bob did select star, but on top of that Bob did run the create table as select, which is, well, should not be happening. So we definitely know that Bob as a user is doing something incorrect, and that is already should trigger some alarms and further investigation and hardening of the security and roles. Another one that you can investigate and use is to check the execution status as fail, and sometime here you would have the query text as redacted, but you can see that this query, for example, the create table my copy was failed at this timestamp. Actually I should add some additional details, but it is possible to check what was the error message, but at least we know that this query text is failing. So the error message for this one was where is it? Here. It was because of me not using the warehouse at all while I was doing this, but then this one, the second error, there was a compilation error that object my copy already exists. So even though the query text here is redacted, we know that it was that same query, and just the error message that something already exists could be potentially suspicious one. And the last example that I wanted to show, you can run a query like this to select the user, start time and query text for all of the queries that were outside of your normal working hours. So you can see, and you would need to adjust the date part of the start time, what is your actual working hours in regards to UTC, because you might not want to have access to your data platform outside of your data working hours, and that should trigger another alert. Alright, so the important takeaway here is that the platform's own telemetry becomes a data set that we can analyze, and instead of treating logs as unstructured files, modern data platforms expose them as structured data, which makes the investigation significantly easier. Security in data platforms is not only about preventing access, it's also about understanding how the platform is used. And monitoring and logging allow teams to answer questions like who accessed sensitive data, what queries were executed, when did it happen, and was the access successful or denied. Because when something suspicious happens, the investigation usually starts with query logs like I showed you before. And as I said, in the next video we will look at the other half of the monitoring process, how to automatically detect suspicious activity and trigger alerts. So if you are interested in that, please stay tuned, subscribe and like this video. See you!